Now we have to study the units of force, the SI unit. That means we have to measure these, how much force it is applied. Okay, so like if we are traveling a distance, we will measure it in kilometers. We will measure it in kilometers or meters. And the time, how we are measuring it? We are measuring it in seconds, isn't it, or minutes, or hour. Okay, likewise, and here also there is some, we in standard, universally some standard units are applied or applicable to all the measurements. Even if it is time, if it is distance, if it is length, etc., whatever it is, there will be some standard measurements. Those standard measurements are called SI units. SI units, standard measurements are called SI units, and this, the SI unit of time is seconds, not minute. So universally, when we are talking about time, we will be speaking it in seconds. The SI unit of length is meter, not kilometer. We will be SI unit, according to SI unit, standard units, we will be measuring it in meters. Likewise, for force, there is some SI unit. The SI unit of force, the SI unit of force is Newton. SI unit of force is Newton. We will call it as Newton, or it will be having another name, kilogram meter square. The SI unit of force, and this kilogram meter square is called as Newton. This kilogram meter square is called as Newton. Okay, so the SI unit of force is very important for us. I have told you it is Newton. The equation of Newton is mass into acceleration. You will study it. So mass is kilogram, meter, acceleration meter per second square. It's not kilogram meter per second square. The SI unit of force is kilogram meter per second square. That is kilogram meter divided by second square. So this is the SI unit of force. You have to note it down. And this kilogram meter per second square is called as what? Newton. Clear? Okay. So that is about the SI unit of force. Now, we are moving on to the next portion of this chapter. Next portion. The next portion is pressure. What is pressure? Have you applied pressure anywhere? Your parents may be pressurizing you to study, always study, and you will be You will be fed up with those names. Okay, so pressure. In our day-to-day life, we are dealing with a lot of pressures. The pressure of studies, the pressure of getting into a good job, the pressure of earning money, the pressure of having a prosperous and a happier life. Isn't it? So pressure is inevitable in our life. Okay, so in physics, what is pressure? What is pressure? I will give you some examples. Okay, so when we are using a knife to cut apple, are we using a big broad knife and cutting it, or are we using a sharp knife and cutting it? We are using a sharp knife. Next, when we are nailing using a iron nail and we want to nail it on the wall, what is the type of edges of the nail? Is it thick one or is it pointed nail? It is pointed, isn't it? Now, when we are moving on to the beach shore, we usually have evenings at a beach shore, etc., just for our leisure time. Okay, so when we are on the beach shore, or when we are in the beach, if we stamp our leg on the sand, if we use one leg and if we stamp it on the sand, what will happen? We will be going down. There will be impression of the leg. There will be impression of the leg on the sand, isn't it? Yes. So, but what will happen? What will happen if we lie down on the sand? Will we go down? Means will we have a big impression over there? There won't be any impression. So, when we stamp on the sand with one leg, that one leg will be making some impression on the sand. But when we lie down, there is no impression formed. Listen, what is happening over there? I have told you some examples, 3 or 4 examples I have told you. So, what is happening in all these conditions, all these cases? Why we are having sharp edged nails? Why we are having knives with sharp edges? Why we are not having an impression when our feet is, when we use our feet and stamp it, there will be impression, but when our whole body is placed, means when we lie down with using our whole body, there is no impression on the sand. What is happening here? I told you, if I keep my hand like this, I am applying pressure on my other hand, isn't it? When I am standing, I am applying pressure on the ground. That there is no doubt in that. Okay, so what is happening when we use a knife? We take an apple, we cut it. When we are cutting it, we are applying pressure. So we are applying force, isn't it? That application of force, if instead of this sharp edged knife, if it was a broader knife, when we apply the force, we couldn't, even if we apply a huge amount of force, we couldn't cut it. So what is happening over here? The knife edge is very sharp. That means the area of the edge of the knife is very small. It's very less. Whenever we are applying the pressure, whenever we are applying the force, we are applying force using this knife. So when we are applying the force on the apple, the whole force should act on a very small area. The huge amount of force, it will act on a very small amount of area, then the effect of force is huge. The apple can be cut easily if the edge of the knife is too sharp, isn't it? You understand the point, isn't it? So if the sharp edged knife is used, the cutting will be more effective or more efficient, isn't it? So the area should be very less. If we are applying some force, that force should be applied on a small amount of area, then the effect will be very high. And if we are applying the same force but using a broader edged knife, that means the area will be huge. So if we are applying more amount of force also on a large amount of area, the application of force won't have a great effect on the apple. It will be smashed. It won't be cut into 2 pieces. It will be smashed. Clear? Okay. So we have to understand that how much area it reduces, the effect of force will be huge. So that whole amount of force will be acting on the small amount of area. So there will be a huge effect of the force which we can see. Okay. The same case is happening in the case of the nail. We are applying, using the hammer, we are applying huge amount of pressure here, and that whole amount of pressure is being concentrated at this edge, and thus it pierces into the wall. The huge amount of pressure we are applying using the hammer, it will be all felt at the small pointed area it is. That pointed area, it will have huge amount of force. So what will happen? We will be able to pierce it. So we are applying pressure on the nail. We are applying pressure on the apple using this knife. We are applying pressure on the wall using this nail. So what is pressure? We are applying pressure. Pressure itself, pressure again, it is force. But this force is related with area. The pressure, the force which is related with the area is called what? Pressure. Force means it's just pull or push. But when the push or pull The push or a pull which is related with the amount of area it is acting upon, that amount of force with respect to the area we will call it as pressure. Okay. So what will happen over here? The area is so small, the area is too small, so what will be the pressure? The effective force is huge, and thus we will say that the pressure is more. We will say that the pressure is more. Here also the knife edge is too sharp, so the amount of area acting is too small, so the force, the effective force applied will be, the effective force will be huge, or it will be experienced, highly experienced. The effective force can be experienced very highly. Okay. Then also we will say what? The pressure is huge. Here in the case, a whole body pressure is being exerted on this, on one leg. So what will happen? At that amount of area will experience the whole amount of force with our body is exerting. Thus it will have an expression on the sand. What will happen to our legs? It will go inside the sand. But when a body, the whole body is being lying down, the whole body area, the force of a body area is distributed along the whole area.